Hello. In this video, we're going to look at some of the subgroups of the real numbers. And by that I mean we're going to look at some collections of numbers that have some significance in the real numbers. So we know the real numbers, or the real number line, as this line with numbers from negative infinity to infinity. So the first thing we're going to do is look at the most important set in there, the smallest, most important set, the natural numbers. These are the numbers that start from 1, and you can keep adding 1 indefinitely. So 1, 2, 3, 4, etc. And really, starting from 1, it doesn't really matter. We do have another set that's very similar called the whole numbers. They start from 0 and do the same exact thing. These are our most basic sets. These are normally referred to as counting numbers. And just really depends on what your field is to decide whether you're going to start from 1 or start from 0. But these are our smallest, most important set in the real numbers. So next, rather than just adding, say, starting from 0 and adding 1, we can talk about subtracting 1. And this would give us the integers. So we're just building off of these counting numbers, and we're adding in this new operation where we're allowed to subtract 1. And we get the integers. So if we think about this number line, we're still missing a lot of things. Right? We have these nice spots, but we're still missing large chunks of numbers in between. And for that, we need fractions, what we're going to call the rational numbers. So I can't list out all of the rational numbers, but I can write what they look like. They look like a over b, where a and b are integers. And, very important, b is not 0, because dividing by 0 is not a real number. So in their fraction form, it's an integer divided by an integer. And when we put these in calculators, these look a little different. Right? So we have these decimal forms. They may look like 0.5, so they stop at some point. Or another example, 0.125. Again, it stops at some point. Or maybe it looks like this. I don't know why that happened. Or maybe it looks like 0.333333 repeated, or we could write that as 0.3 repeated. So we know a number can be written as a fraction of integers if it either stops at some point or it repeats in some nice way. And that's how we know if it looks like a fraction, or if we can write it as a fraction. So we're still missing a few real numbers, and these we're going to call the irrational. So the irrational numbers are really just the numbers that are not rational. We really don't have a better definition for it. So we'll say real numbers that are not rational. All right, so what do those look like? Well, based on our decimals from the rational numbers, we can say that they're going to be the numbers where their decimals do not end, right? It doesn't look like 0.5, and does not repeat. So it does not end like 0.5, it does not repeat like 0.3 repeated. And these will usually be the square root of some number, maybe 3, Or there'll be some very, very special numbers that we are kind of familiar with, pi or maybe e. So let's put all of that together. We have our real numbers. Everything in this box is going to be real. And from our definitions of rational and irrational, our real numbers are split down the middle. So we have rationals on this side and irrationals on this side. No overlap. So rational is going to come back again and again and again and again in this class. And when you think rational, you need to think fractions. A over B, where B is not 0. And when you're thinking irrationals, you're thinking the square root of something, or maybe like pi. Though we should be careful, because if I say something like the square root of 4, well, I could rewrite that as 2. And that's not quite an irrational number, because again, its decimal form is ending, and I can write it as a fraction of integers. So we'll want to be careful about that. All right, so inside the rational numbers, we have the integers. So these are fractions where the denominator, or b, is 1. So -3, -2, -1, 0, 1, 2, 3, etc., both sides. And so we can write them as fractions, and the denominator is just 1. Smaller than that, we have these counting sets. The whole numbers, which is starting from 0 and counting up. And finally, the natural numbers, starting from 1 and counting up. And I've written it in this way so that you can see all of the natural numbers are in the whole numbers. All of the whole numbers are in the integers, and all of the integers are in the rational numbers. And that the rational numbers and irrational numbers have no overlap. They are disjoint. And that is all of the sets and the subgroups in the real numbers.